Let's begin. Okay, so today we're talking about special right triangles. Remember yesterday we talked about the Pythagorean Theorem, and we talked about how the Pythagorean Theorem allowed us to find side measurements. So we can only use the Pythagorean Theorem when I know two sides, right? Because if I gave you a triangle that looked like this, you don't have to draw this on your paper, but if I gave you a triangle that looked like this, and I just told you that this side was 8, and this was x and y, if you tried to put that into the Pythagorean Theorem, that wouldn't work, right? Because you would have two missing sides that you don't know. Okay, so what do we do when we don't have the ability to use the Pythagorean Theorem? That's what we're going to talk about today, okay? We have special triangles that we're going to talk about. We're going to have 30, 60, 90 triangles, and we also have 45, 45, 90 triangles. And each triangle is going to have special properties that go with it, like a special formula that goes with it, okay? So, maybe if I can get this to move. Too fast. Just a second. There we go. Okay. So the first thing we're going to do is we're going to find the length of the diagonal of a square whose side is 8. Okay, so here's the thing. I have this square here, and you guys see that I have an isosceles triangle, right? I have an isosceles triangle. If this is an isosceles triangle, what do we know about these angles down here? They're congruent. Okay, so if I've used 90, how much is left for those two angles? 90, right, for each of them. But if they're congruent, that means each of these has to be, I heard Nick say it, they each have to be how much? 45, right? Because if these are congruent angles, and I have 90 to split between them, then they're each 45 degrees. If this side over here is 8, how much is the top side? 8. So let's put an 8 up here for this side. And now I'm going to use this right triangle here to find out how much my x is. Okay, so again, 45 degrees are the angles. They're not the side measurements, they're the angles. So if I use my c squared equals a squared plus b squared, for that green triangle, which one is the c value? The x, okay. And then my a squared and my b squared are both going to be 8 and 8. Would you guys agree with that? Okay. So I have 8 squared. Okay, go ahead and solve this out. You know how to do this. Break your radical down, please. What are you guys getting when you break down 128? Should be 8 square root of 2. You should have 3 pairs of 2's with another 2 left over. So it should be 8 square root of 2. Okay? All right, letter B. It says, find the length of the diagonal of a square whose side is 5. So the first thing we need to do is what? Draw a square. Good. And in this one, all my sides are 5. What is the length of the diagonal? Okay, so again, we can set up c squared equals a squared plus b squared. Go ahead and plug in. What are you getting for the square root of 50? 5 radical 2. Good. Okay, so let's look at these two problems that we just did. Do you see a pattern between these two answers? This one and this one. Does anyone see a pattern? Okay, 2 is always inside the radical. What else? Where does that other number come from? It's the length of the side, right? Over here, this 8 is the length of the side. This 5 is the length of the side. And each time, it's radical 2. Do you guys see that? That's the pattern that's going to continue if you have a 45, 45, 90 triangle. Okay, so you guys have this blank down there in that box where it says formula. The formula we're going to write is this. The hypotenuse equals one of the sides, but what do we call the sides of the triangle? What do we call those? The legs, okay? So instead of side, radical 2, we're going to say leg, radical 2. So now that we've used the Pythagorean theorem, let's just now take the shortcut and use this formula. So on example C, it says find the length of the square whose diagonal is 12. So the first thing I should do is what, always? Draw a square. Okay, so on letter C there at the bottom, let's draw a square. And we can mark them congruent because we know they're congruent. We know the diagonal is 12. This time it tells me to find the side. Well, here's the hint. Because this is a square, this means I automatically have a 45, 45, 90 triangle. So whenever you see this word square, you know you automatically have a 45, 45, 90 triangle. And if you have a 45, 45, 90 triangle, you can always use this formula. Hypotenuse equals leg times the square root of 2. Always. Now in this example, we know the hypotenuse. So how much is our hypotenuse? 12. That's going to go in here for my hypotenuse. Do we know how much the leg is? No, we called it what? X. How are we going to get x by itself? Let's think about this. If this was just 12 equals 2x, how would we get x by itself? What would we do? Divide by 2, right? Same example. We're going to divide by the square root of 2 on each side. Cancels out here. But what do we do when we have a radical in the denominator? We're not allowed to have that. What do we have to do? What? All right, what is that called? Good. We have to rationalize now. So that means I'm going to take 12 radical 2. I'm sorry, 12 over radical 2 times radical 2 over radical 2. This is why we practice this on Monday. When I multiply the numerator, 12 times radical 2, remember outside with outside and inside with inside. Well, 2 is on the inside and 12 is on the outside, so it just stays 12 radical 2. What about in the denominator? It's the square root of 4, right? But what is the square root of 4? 2. Is this finished? Can you simplify anything here? Would it be 6? Elena says maybe 6. What can we do with that 12 over 2? You can reduce it, and you should reduce it. So your answer is x equals 6 radical 2. So here's the thing. This skill is not new to you. We've practiced this for 3 days now, almost. Okay? The only thing that's new is your formula. That's really the only thing that's new here. Okay, but you know how to use your formula, and we'll practice this a little bit more. Any questions on letter C? Yes?
Can you rationalize these cross multiply?
No, you multiply straight across. You only cross multiply when there's an equal sign in between the two of them. Okay? All right, the second type of special right triangle is a 30, 60, 90. And here's the hint. When you see this word, equilateral, you should be using a 30, 60, 90 triangle. So it says, find the length of the altitude of an equilateral triangle whose side is 18. So we've already drawn it for you. If this is equilateral, what do we know about AD and DC? What? They're the same, right? And these are each 9. We also know that x is the altitude. And so if I want to find the altitude, I know two sides. And when I know two sides, what formula can I use? When you know two sides? C squared equals A squared plus B squared. Adela, what's the C squared in this example? Which one's my C value? 18. Good. So then we have 9 squared plus x squared. Go ahead and solve this out. You know how to do it. I'd like a radical answer, please. You guys doing okay breaking it down? You should have a bunch of 3s. So I have two groups of 3s. and 1 3 that's left over, which gives me 9 radical 3 equals x. Okay, so this, when we have a 30, 60, 90 triangle, our pattern is a little bit different, and we have a couple other things to consider when we're talking about a 30, 60, 90. Okay, so in this diagram down here, across from 30 degrees is this smallest leg. Remember we did in chapter 4 which leg is the smallest across from the angle? Do you guys remember talking about that? Okay. So it would make sense that across from the 30 is going to be the smallest side, right? So we're going to call this the short leg. So across from 30 is called the short leg, and we're going to abbreviate that with SL. Across from the 30 is the short leg. So what might we call across from the 60? Long leg, exactly. Okay, so across from 60 is what we call the long leg. We're going to use LL. Make sure you're using capital L's so that it doesn't look like the number 11. And then, of course, across from the right angle is which side? Good, the hypotenuse. So over here, we know that this is our hypotenuse. Now, because we have two different sizes of legs, we have two different formulas depending on what's been given to us. Okay? So we have, the first formula we have says your long leg equals your short leg times the square root of 3. Let's look at that example above. Do you guys see in that example? The long leg was x, right? And the short leg was 9, and our answer turned out to be 9 radical 3, right? So I would maybe up there at the top where you have 9 radical 3, I would maybe make a note that, hey, this 9 came from the short leg, right? And you have equals x. This x came from the long leg. So you do have long leg equals short leg radical 3. You have that already. The other formula that we're going to use is when we're trying to find the hypotenuse. Look at that example up there. Look at, you have the hypotenuse is 18, and the short leg is 9. How do you think those are related? What did we do to the short leg to get to the hypotenuse? Doubled it, right? Or we cut the hypotenuse in half. Okay? So the formula says if you take your short leg and you multiply that by 2, you should get your hypotenuse. So these are the two formulas you need to know for 30, 60, 90. So let's do an example. It says in a 30, 60, 90 triangle, the shorter leg is 6 feet. Find the length of the other two sides to the nearest tenth. Tenth means how many decimal places? Tenth means 1 decimal place. All right, so let's try this. The first thing we need to do is, excellent. So I'm going to draw a triangle here. I'm going to say up top here, this one is 30 degrees. Over here is 60 degrees. So where's my short leg? At the bottom, right? Let's use x for our long leg and y for our hypotenuse. So we have two formulas, but because we've been given the short leg, that's what we have to start with. And so some of you maybe need to make yourself a note. We were given the short leg, so start with the formula that has short leg in it. Look back at your formulas. Which one has short leg in it? They both do. So in this problem, it doesn't matter which formula you start with. Okay? So I'm just going to start with a hypotenuse. Let's find our hypotenuse first. So guys, because these formulas are new to you, I need you to please be writing these formulas down every single time. Okay? So I want you to start with hypotenuse equals short leg times 2. Every single time you're writing these formulas down. If you ask me to come help you on a paper and you do not have your formulas written down, I'm not going to help you. Because this is all just plugging into a formula. We know our hypotenuse is y. We know our short leg is 6 times 2. What is 6 times 2? That's it. And yes, some of them really will be that easy. Okay, what about the next formula says long leg equals short leg times 2. I'm sorry, short leg radical 3. This is why we write them down. We used x as our long leg, and our short leg is 6, radical 3. Now, not all of them are going to be that easy. Some of them you're going to have to rationalize the denominator, right? So I want to do an example real quick. Let's draw another picture over here. I'm going to erase this. Okay, so let's draw another picture over to the right side of your paper. If I tell you that this is 30, this is 60, and I'm going to give you the long leg, which is 4. Okay, and I want you to find x and y, so let's put an x and a y in here. Here's my x, here's my y. Short leg is not always at the bottom. Short leg is always across from the 30 degrees, right? So even though my diagram might be a little bit deceiving, looking like that one's shorter, we always have to go across from the 30 to get our short leg. Okay, so what have we been given? What piece have we been given? We have the 4, and 4 is across from 60. We have been given the long leg, right? So I've been given long leg, so I have to start with my long leg formula. Again, maybe some of you need to make yourself a note. You were given long leg, so you have to start with long leg. Okay, so if my long leg is 4, I'm going to plug that into my equation. My short leg, we said, was x, radical 3. How do we get x by itself? Divide by radical 3. And now what's the problem? You gotta rationalize. Okay, do it. You know how to do these. I'm getting 4 radical 3 over 3. Is that what you're getting? Okay. That's kind of an ugly number, but whatever. It is what it is. You're going to have problems like this. Okay, so now the last thing to do is, now that I know what my short leg is, right, essentially, I found out that my short leg was 4 radical 3 over 3. I know that that's what x is. Now I can find y by using hypotenuse equals short leg times 2. Well, my hypotenuse is y. My short leg is this big thing, and I am going to write this, 4 radical 3 over 3 times 2. Yee. How are we supposed to handle that? Hang on. Let's think about it for a minute. 2 is a whole number, and I think what Dakota was getting ready to say is we put 2 over 1. The rule for multiplying radicals is what? Good. Outside with outside, inside with inside. Notice we have 4 on the outside, we have 2 on the outside. What is 4 times 2? 8. So now I have 8 radical 3 over 3. And that's it. Okay? Do you have any questions on this? Now, the thing that I want you to understand is that students wonder which formulas that you use. Well, it depends on whether you've been given a 45, 45, 90 or whether you've been given a 30, 60, 90. So look at your diagram, and that's going to tell you which formulas you need to use. Okay? All right, when we get back from break, we're going to start on our homework.